Okay, in this video, we're going to go through the homework for 6.1 part 2. So it's your obligation to follow all of this. Okay, so I'm going to start writing things down. I'm on page, 492. So this is going to be page 492. And initially, I'm going to do 5 to 15 odd. And so 5 to 15 odd, they want me to change degrees to radians. So 5 is 20 degrees. So I'm going to change that to radians by saying times pi over 180. 10, 10, 1, and 9. So that equals pi over 9. And then, so what did I say? I had 5, to 15 odd. So that means my next one's going to be 7. So 7, it's 54 degrees times pi over 180. So I'm going to divide this by 2. That's going to give me what, 27? Divide that by 2, that gives me 90. Divide that by 3, that gives me, well, actually, divide that by 9, it gives me 3. Divide that by 9, it gives me 10. And I have 3 pi over 10 for an answer. I'm going to check these when I'm done. Hopefully they're going to be correct. I'm going to check in the back of the book. Okay, I have negative 45 degrees times pi over 180. Okay, so 9 goes into this 5 times. So negative 5, 9 goes into this 20 times. 5 goes into negative 5, negative 1 times, 4 times, negative pi over 4 is what I'm getting. 11 is my next problem. 11 is 100 degrees. 100 degrees times pi over 180. Divide by 10, divide by 10, divide by 2, divide by 2. I'm getting 5 pi over 9, and that brings me to 13. And for 13, the degree is 1,000. So this is 1,000 times pi over 180. Divide by 10, divide by 10, divide by 2, divide by 2. I think that's it. And then 50 pi over 9 is what I'm getting. And we had to do one more. We had to do 15. So looking at 15, what do I have? My degree is negative 70 times pi over 180. And divide by 10, divide by 10. And that's going to be negative pi over 18. Okay, I'm going to stop the video and check my answer. Okay, so I found one little error, and it's right here. I just forgot to bring the 7. So I'm going to move this over, and I'm going to make it negative 7 pi over 18. Okay, so the textbook breaks those down into decimals, but we had said keep your answers as fractions. Okay, so that's what I want you to do. Okay, so now we have 17 to 20 all. I'm going to be over here now. So 17, looking at 17 in the textbook, they want me to go from radians to degrees. So 17 is 7 pi over 6. So if I'm going to degrees, I'm going to make this 180 up here. And 6 goes into 180 30 times. The pi's can cancel. And that's 210 degrees. So then 18. So here's 18. 18 in the textbook is 4 pi over 3. 4 pi over 3 times 180 over pi. Remember, you want to get it into degrees. And 3 goes into this 60 times. And 4 times 60 is 240 degrees. 19. The book says it's 5 pi over 6. 5 pi over 6 times 180 over pi. Pi's cancel. That's 30, right? 30, and then 5 times 30 is 15. Carry the 0. Then we have 20. 20 is negative 3 pi over 2. Negative 3 pi over 2. Remember, your answer is going to be negative 180 over pi. The pi's go. 2 goes into 180 90 times. Negative 270 is what I'm getting for an answer. And so that gives me 17 to 20 all. I'm going to stop the video there and check. Okay, so I can only check in the book the odd ones, and I rechecked my 18 and 20. I think I've done it correctly, so I think we're good to go. Okay, so now I want to start doing the remaining problems. So I need 25, 27. So 25 is going to be, what are they asking me to do? I'm still changing from radians to degrees. So this is pi over 10. I want degrees, so I put the 180 over pi. These guys cancel. 10 goes into that, and I'm left with 18 degrees. That's 25. 27 is next. 27 is negative 2 pi over 15. Negative 2 pi over 15 times 180 over pi. So the pi's can cancel. Let's see, 3 goes into this 5 times, 3 goes into this 60 times, and I'm getting negative 120. Oh, I can continue going. Okay, so 5 goes into 60 how many times? So 60 divided by 5. Okay, that goes in 12 times, so this is a 12. So that means that I have a lower number, which is better to deal with. So negative 2 times 12 is negative 24 degrees, and that's 25 and 27. 31 is a different kind of problem, so I'm going to stop. Okay, so these are all set. So let me go to the next page, and now what I want to do is 31, 33. So 31 is coterminal angles. The measure of an angle and standard position is given. Find 2 positive and 2 negative that are coterminal with the given angle. Okay, so I want to do 31. And the given angle is 3 pi over 4. So I'm going to have to add and then subtract 2 pi. But 2 pi is not going to work until I convert it to, so 3 pi over 4 plus and minus 8 pi over 4, okay? So now let's start our work. 3 pi over 4, I want to get positive angles. I'm going to add 8 pi over 4, and I get 8, 9, 10, 11 pi over 4. So that's one of them. Then I add another 8 pi over 4, and I get 19 pi over 4. That's the second one. So here are my 2 positive coterminal angles. And then let's get our negative. So I'm going to say 3 pi over 4 minus 8 pi over 4. That gives me negative 5 pi over 4. And I'm going to go more negative. That gives me negative 13 pi over 4. And those are my negative answers. Okay, so that's 31. Okay, so then we'll do a couple more, then we'll check. So I have 33. So 33 says that they want me to the measure of an angle in standard form. Okay, so I'm still doing the same thing. So the angle they gave me is negative pi over 4. So I have negative pi over 4, and I know from the previous example that I'm going to have to add and subtract 8 pi over 4. So let's go for positive angles first, and that's going to give me what, 7 pi over 4. That's one of them. Add another 8 pi over 4, and that gives me 15 pi over 4. Okay, so now I'm going to go for the negative ones. and I'm going to subtract 8 pi over 4. That gives me negative 9 pi over 4. I'm going to go more negative, and that gives me negative 17 pi over 4. So here are my answers. Here's a positive. Here's a positive. Oh, I'm so sorry. Hold on a second. I didn't want to do that. So let me go back and back. Okay, let's try that again. Okay, here's a positive, and then here's a second positive. Here's a negative. Here's a second negative, and I'm going to check those right now. So okay, so those were correct. So that brings us to 37. And for 37, it says that they're going to give me two angles, and they want to know if they are coterminal angles. So I have 5 pi over 6, and I have 17 pi over 6. So let's think about this. I always add 2 pi, but I have to add it in 6. So I'm going to multiply that by 6 over 6. So that's 12 pi over 6. So if I had 5 pi over 6, and I added 12 pi over 6 to it, I get 17 pi over 6. So yes, they are coterminal. Okay, so that's 37. That brings me all the way down to 47. They want me to find a coterminal that is on the circle between 0 and 2 pi. So 47 is 19 pi over 6. So I just did the 6's. So why don't I subtract 12 pi over 6? I think this one's too big. That gives me 7 pi over 6, which should be a little bit bigger than pi. So it's going to be in the third quadrant. So I think I'm good. So is that true? Yep. So I'm going to be in the third quadrant because pi is here and 7, 6 is greater than 6, 6. So the angle is going to be right here. So that's my angle for 47. After 47, we're going to 49. Another angle, same idea. Now this one is much bigger. So this one is 25 pi. So I'm going to take away 2 pi, but how many times I need to take it away to get on a circle? So if I take it away 12 times, doesn't that give me 24 pi, which would give me pi, which would be a quadrantal angle right here. So pi is my answer for 49. Okay, so that's 47, 49. Okay, 53 is different, so I'm going to stop and check my answers. Okay, both those answers are correct. Moving on. So now I'm going to go to 53. And 53 is find the length of a circular arc, the radius of the arc of the circle, and the central angle as indicated. So here is 53. And 53 gives me this picture. So there's a circle. I have this, whoops, sorry. Let me go back. I have this angle. So here's my center of it. So it's going like this and like that. And this angle is 5 pi over 6. And the radius is 9. So radius equals 9. Theta equals 5 pi over 6. What can I find? It says find the length, the radius, or the central angle. So it looks like I'm going to find the length. So S equals R times theta. R is 9. Theta is in radians, so I can use that theta. Okay, so that's going to give me 3 goes into 6 2 times, 3 goes into 9 3 times. That's going to give me 15 pi over 2 for my arc length. And that is 53. Okay, that brings us to 55. So 55 has the following picture. Same idea. I'm going to draw a circle. And once I have a circle, I find the center and I say that that's 5. and they are looking for the theta, but they're giving me the arc length, the sector length of 10. So, yeah, it's this, let me see, hold on a second. So they're giving me, I want the length of the circular arc. Okay, so I want that, that's this. I don't have theta, but I do have the r. So let's make this a laundry list here. My S is 10, my r is 5, so I need to find my theta. Well, I know S equals r times theta, so plug in your r of 5, your S of 2, so theta must equal 2. So theta equals 2 for 55. Okay, that completes 55. So then that brings us to 57. 57 is a word problem, so I'm going to write down what they tell me. So it says find the length of an arc that subtends a central angle that measures 2 rads. So theta equals 2 radians. And in a circle of radius 4. Radius equals 4, and they want the S. So I know S equals R times theta. My R is 2. My R is 4. My arc, my central angle is 2. So therefore my length is going to be 8. Okay, so that's 57. That brings us to 60. 60 says an arc length 15 feet. So that's the arc length. So that's S equals 15 feet. Subtends a central angle theta. Theta is unknown. Theta is unknown. But the radius is 9. They want us to find theta in degrees and also in radians. Well, I know the equation is going to get me it in radians. So S equals R times theta. If S is 15 and R is 9, then theta must be 15 over 9. 3 goes into 9 3 times. 3 goes into 15 5 times. So theta has to be 5/3 radians. Okay, so this is tricky because this is definitely in radians, even though pi is not present. If I want it in degrees, I have to multiply by that. Now, in this situation, I'm going to have pi in my degree measurement, but that's okay. Okay, so 3 goes into itself 1 time, 3 goes into 180, 60 times. 5 times 60 is 300 over pi. Now watch this. These are degrees. Okay? So theta equals this in degrees, that in degrees, and this in radians. Okay? So be careful in your understanding of that. Okay, so that brings us to 61. So 61 is telling us find the radius of a circle. So the radius, I don't know. If an arc length of 15, so the arc length is what? The S is 15. On the circle subtends a central angle of 5 pi over 6. Is that in radians? Yes, it is. So I can use my formula. S equals R times theta. I write it every time. That's 15. R is what I'm looking for. The angle is 5 pi over 6. Okay, to get R by itself, I'm going to multiply by 6 over 5 pi on both sides. Okay, so 5 goes into itself 1 time, 5 goes into 15 3 times, and my radius ends up being 18 over pi. And that's a fine answer. Don't worry about that. Okay, so I have 61. 63 is next. 63 gives me a picture. It's going to give me area. I'm going to stop for a second and check my answers thus far. Okay, I was able to check everything but 60 in the back of the book. And 60, I went back over it. I think that looks okay. All right, let's go to 63. They give us a picture. They give us actually two pictures, and they want the area of the sector shown in each figure. So let me just draw A and B. Here's your A. Here's your circle. Here's your center. Here's your angle given to me in degrees. Okay, that's going to be a problem. And the radius is this, and they want the area. Okay, so then for B, we'll do B in green. B, I have a circle again. Okay, here's the center. I now have an angle that is in radians. So that angle is 0.5 radians, and I have a radius of 10. Okay, so let's deal with this one first. Okay, first off, I have to say 80 times pi over 180, divide by 10, divide by 10. 2 goes into 8 4 times, 2 goes into 18 9 times. That equals 4 pi over 9 in radians, and that's my angle. Okay, so now the question is, what does area equal? Okay, so you have to look up that formula. It is area equals 1/2 r squared times theta. So let's figure out the area now that we have the angle in the correct way. So this is 8 squared and times theta, which is 4 pi over 9. Okay, so 1/2 8 squared is 36, and then 4 pi over 9. 9 goes into 36 4 times. 2 goes into 4 2 times. That leaves me with 8. 2 times 4 is 8 pi for the area. Okay, the next one should be easier because I don't have to do any conversion. So again, I write my formula first. Area equals 1/2 r squared times the theta. This is 1/2. My r is 10. I'm going to square it. Theta is 0.5. So that's going to be 1/2 100 times 0.5. And why don't I just put this in parens? And this is 2. This is 50. So 50 times 0.5 is 2.5 is my area measurement. Okay, so that's 63. That brings us to 65. We are getting there. 65 is find the area of a sector. Central angle equals 3 pi over 4 in a circle of radius equals 8. So area equals 1/2 r squared times theta. So that's going to equal 1/2 r squared is going to be 8 squared, and theta is 3 pi over 4. Area equals 1/2 times 64, 3 pi over 4. Okay, 64 divided by 4 is 16, right? So 4 goes into 64 16 times. 2 goes into 16 8 times. That's going to equal 24 pi for my area for 65. Okay, 67 is my next problem. 67 says the area of a sector of a circle. So the area is 90 meters square. The central angle, the angle equals 160. That's a problem. The radius is unknown. Okay, first things first, 160 times pi over 180, because I have to have my angle in radians. Okay, 2 goes into 2 goes into 16 8 times. 2 goes into 18 9 times. 8 pi over 9 equals my angle in radians. That's what I need. So if I know that area equals 1/2 r squared times theta, they told me the area is 90. This equals 1/2. Okay, so r squared is what I'm looking for. And then theta is 8 pi over 9. Let's see what I'm going to do. I'm running out of room here, so I'm still going to do what I'm doing. So I'm going to say 90 equals r squared times 8 pi over 18. Multiply both sides by 18 over 8 pi. 18 over 8 pi. Okay, so what am I going to do? Well, let's see. I could say, okay, so 2 goes into, well, let me see. What's 90 divided by 4? Is that going to help me? No, of course not. Okay, so maybe I'll just reduce this. So if I say 18 times 90 divided by 8. Okay, so I'm going to have to play around with this. Okay, so 4 goes into 8 2 times. No, I don't know. 2 goes into 8 4 times. 2 goes into 80 45 times. What is 45 times 18? And that's 810. So this is 810 over 4 pi. Okay, so I don't think 810 is divisible by 4, but I do know that 810 is divisible by 2. So let's make this 405 over 2 pi. And what does that equal? That equals r squared. So therefore, r equals the square root of 405 over 2 pi. And I'm going to leave that be for right now because that's an exact answer. Okay? So even though I shouldn't have a radical in the denominator, I'm going to leave that. Okay, so that brings me to 69. And 69 says a sector of a circle of radius 80. So radius equals 80. Has an area of 1,600 miles squared. Find the central angle in radians of the sector. So they want the central angle. Okay, so that's interesting. So I'm going to say area equals 1/2 r squared times theta. They gave me area. If I take my 80 and I square it, so 80 squared is going to be 600 times theta. 2 can go into that. 3200. I have 1600 divided by 3200. And I believe that that is 1/2. So 1/2 radians equals my theta. Okay, so I'm going to take 1 second and check these answers. So okay, so I just want to go back a little bit. Okay, 69 is fine the way it is. Okay, 67, if you keep this and then work to simplify this using good math, you end up getting what I have highlighted in yellow, which is the answer that they have. Okay, so that's the correct answer there. 65 was fine. 63, I kind of lost my head. 0.5 times 50 is 25 and not 2.5 for 63B. And for 63, 8 squared is 64, not 36 as I wrote down. So I should get 128 pi over 9. And 61 was fine. Okay, so I hope this helps. This was a lot of good work. I kind of talked through reducing things. I talked through using the formula, writing it every single time, being aware that you have to absolutely have your angles be in radians if you're going to use those two formulas for sector length and sector area. So I hope this helped. You may need to spend some time on this material.